Your character can move, but it looks like this, and you'd prefer it would look like this, good news, you clicked the correct video. In the last video, we created this player based on this spreadsheet. This contains also several animations that are basically just differently drawn positions of the same player. And we will use those different sprites to animate the character. So let's start. And if my layout confuses you, check out my video on how to customize Unity. So we already sliced our sprite sheet into all those single sprites. One of those sprites currently represents our character with a sprite renderer. By now, changing this sprite on a regular basis, we will make the player look animated. Fortunately, most of the logic will be handled by Unity. We start by adding a new component to the player, an Animator. This needs an Animator controller. We will store the Animator and all the animations in a new folder called Animations. In there, I create a second folder specific for this character, which is named Player. Every animated object will have its own folder. This makes the project more structured. Now right-click, Create, Animator. I give it a name of the character and also note that it's an animator. Now we can open the player again in the inspector and drag and drop this animator in the controller slot. So I already pinned this Animator tab here next to the scene, but you can also open the window by going to Window, Animation, Animator. Currently this animator is empty because there are no animations for this character. So we will come back here later and open another window. Go to Window, Animation, Animation. For me, this window is already pinned down here next to the game. You should always be able to see the scene window and the animation window at the same time. And if the side of your player is distracted, like it is for me, you can disable the visibility of gizmos by clicking at this icon. Just be aware that everything is now hidden and you won't be confused later on. Now we can create the first animation. Select your player and you should see this Create button here. Then just click on Create and the saving dialog of your OS should open. Make sure you selected the correct folder, and now let's name the first one player_idle down. Even though we are in the player folder, I still name every animation in here in reference of the according character. The first word after the underscore is the art of animation, in this case idle, so our player won't move. The second word is the direction. Currently the player is facing downwards, but of course we want him also to be able to look in the other three directions. In your animation window, this animation is now selected. Currently there only is this one. On the right side is this timeline, where we can now define different keyframes. Basically every animation consists of a start and an end position. If possible, the time in between will be a transition between those states. Now in our case, we want different sprites to show. When clicking Add a property, you can see also the properties from the player object, which could be animated. There might be some interesting things you could do, but it is very simple for us now. In your project window, go back to the sprites. Just grab one, as an example, and drag it into the timeline. You can see the player immediately changed its sprite. Taking a detailed look, the sprite in the sprite renderer changed. Let's grab another sprite and drag it beneath the current one. To show a preview of this animation, you can click this little play icon. Now this looks strange. That's because we jump immediately back to the first sprite after setting it to the second one. Copy and paste the first animation at the end of the timeline. You could also drag and drop the sprite into the timeline again. Now the animation transitions from standing to jumping, and after the same past time, back to standing, and then the animation loops. Animating characters with single movable sprites can get much more complicated. But for this kind of animation, This was the most important thing to know. Now, let's fix this to make the player idle down. Highlight all keyframes and delete them. Now the previous sprite selected on this object is visible again. It was not overwritten, just hidden because of the active animation that was previewed. Well, this is idle down, but we can't rely on this. It must be in its own animation, because there will be no animation-free states anymore. So let's grab the 22 here again and drop it right at the beginning of our timeline. So the thing is, this sprite sheet here does not have a second idle animation. It is also not necessary, but relatively common for games because your player looks more lively. But what does this mean for our animation? Right, it will only have this one keyframe. No need for more. Of course, we will use several ones when walking, so don't worry, we will do this later. So idle down is done. Now we just need to repeat this for the other three. Click here at the name and you can create a new clip. Name it player_idle left. Now just look for the sprite where your character faces left and drag and drop it at the beginning of the timeline. When hitting this preview button, your character should now face left. Let me quickly repeat this for the other two directions and do this as well. Now I have those 4 animations in my folder. Let's get them to work. Go back to your Animator we opened earlier. Here you should now see those 4 animations, because we already connected those to the player, because it was selected in the hierarchy. If you don't see them, then this doesn't matter. Highlight them all and delete them. Yep, because we won't use those animations manually, but rather use something called a blend tree. Right-click, create state, blend tree. In your inspector, you can rename it. I name it idle tree. This blend tree will calculate which animation to use based on some given variables and rules. Here on the left, under parameters, the blend tree created a new variable called blend. But this is not what we want, so again, delete it. We will switch between 4 states: up, right, down and left. Like we learned from the movement, those directions will be reflected by the x and the y axis. So based on those 2 values, we can definitely know in which direction the player should face to. Great, so let's add them. Click at the plus icon and select float, because our numbers are somewhere between 0 and 1. Create one for x and one for y. Now double click on the idle tree. This will open it. You can see this at those breadcrumbs here, and also go back to the previous view. The idle tree only has this blend tree component. In the inspector, you can see the blend variable we deleted. We don't want a one-directional blend, but 2 directions. So select 2D simple directional. Adjust the variables to match x and y. Now let's make the magic happen. Click at this plus and add a new motion field. Do this 4 times until you have those 4 slots. I will now drag and drop my animations in there. Be careful, I will order them like a compass, starting with north. So up, right, down, left. Now we need to define how x and y should be when this animation is active. So when the player is facing up, x must be 0, so there is no horizontal movement. There is only upward vertical movement, so y is 1. This would represent pressing the W button. The right direction, represented by the A button, is only a horizontal movement in the right direction, so x is 1 and y is 0. This scheme now also applies for the other 2 directions. If you are unsure about the values, you can see those blue diamonds here. They represent the 4 motions, so just grab one and move them accordingly. Then just fix those numbers. The red little dot here is a helper for you. It simulates how those 2 variables, x and y, could be, and how this blend tree reacts to it. So based on these two variables, the tree chooses the most matching direction. This is visible with these blue lines here. All we need now are the actual values for x and y when pressing the keys. This is done via code. So let's switch to the player movement script we created in episode 1. If you don't have any movement yet, I recommend to watch my part 1. Otherwise, you might have your own movement script somehow, so you need to integrate the upcoming logic there. Like we referenced the rigid body that is on our player, we can now reference the animator we added earlier. At first, add the private variable of type animator. In the awake method, we then can fill this variable with the component that Unity will find on our player. Now, whenever our movement input changes, we want to reflect this in the animator. So we are going to update the animator variables in the onMovement method. Doing it in the fixed update loop would happen too often for the same x and y values as they were before. You can do this, but it's not necessary in our case. The animator component contains a method called setFloat, which we need, because we made those variables floats. The first parameter is the name of the variable. In my case, just an uppercase x. The second one is the actual value we want to set. Since we only have a vector 2, we are going to extract only the x value of it by simply writing .x. Do this for the y value as well by adjusting the name and the value. When testing, you can see that the player looks in the direction he is moving to. But after releasing the movement keys, he will instantly look back up. This is because we also set those variables to 0 after releasing. 2 zeros will set the blend tree to the north position. But of course we want to look in the last direction we moved to, so we should prevent this setting of 2 zeros. We already did this in variant 2 of the movement options. We simply checked if at least one of the vector 2 values, either x or y, is not 0. Then we executed the code. Let's do exactly this for the setting of those two animator variables. If x is not 0 or y is not 0, then update both variables of the animator. Testing this, your player will now stay in the wanted direction. But of course he is still not animating a movement. For this, let's set a new variable in the animator. This will be of type Boolean, so either true or false, yes or no. This will be the indicator of the animator if the idle animation or the moving animation should be played. I call it IsWalking, and it can be false or true. This is the default value, and we want it to be false by default. You can also set a default variable for x and y, and if you observed closely, you saw that the initial game start position of the player is 0, 0, so he looks up. Setting y to -1 will make the player face south or downwards in the direction of the camera. Before we are going to create the walking animations and the animator logic, let's make sure this Boolean variable will work correctly. Switch back to the code. So in here, we only set those values when we are moving. So we already have the logic for the Boolean variable. So in this if statement now, call the setBool method instead of setFloat. The first parameter is again the name, and the second parameter will just be true for our value. Of course, we also need to unset it. For this, add an else statement. This is the equivalent to the first statement being false, or our player is not moving. So set the bool here as well, but this time with false as value. Let's see if this works. Make sure your player is selected in the hierarchy. Then you should see the current values of the animator variables when in play mode. Whenever my player moves, the IsWalking variable is true. Now, whenever this value is true, we can play animations from a second blend tree that contains the movement animations. Unfortunately, those don't exist yet. But good for us, we now know how to do it, so let's create them. At first, let's take a look in our sprite sheet and get a quick overview of how those animations will look like. Looks like we have two movement steps, where either the left or right foot is at the front. This is basically enough for an animation, especially for low-res pixel art like this. But then we also have those steps in between, where the player is standing, so that could be the step when both feet are at one level again. Select your player and go to the Animation tab. You should now see your animations. As we learned earlier, click here on the left and add a new animation. I name it like my schema, but now the animation type will be called Walk. Then let's go to the sprites and look for the Walk Down sprite. It's this one here, number 18. Drag and drop it into the timeline and repeat this with the other foot, number 20. Don't forget to copy and paste the first one at the end, otherwise this won't work. Then your animation should look like this. Yeah, well, at least his feet are moving. You can now easily change the overall timing by selecting all keyframes and then dragging this blue marker. This helps adjusting the length or speed of the animation. But it looks way too stiff, so let's drag and drop the set third frame in between both steps. Now the whole player moves. Well, except. But at least he does not look like a robot anymore. I will just manually adjust the timing to make the time between the frames equal, because dividing 15 by 2 won't work. I make steps of 8 frames. And if you are curious, you can see the frames on the left. And this 1 second mark here equals 60 frames. Under these 3 dots here, you can select if you want to see the timeline in seconds or frames. And when showing the sample rate, you see that 60 frames equal 1 second. You could also change this, but unless you have an explicit reason, it's fine this way. Our movement animation now needs a little longer than half a second, which might even be a little bit too fast, but I leave it like this. This is something you have to decide for yourself. Now we need to repeat this for the other 3 directions as well. Be careful that you like your timing now, because it must be the same for all other animations, otherwise this would look really strange. And after setting all 4 animations, changing frames or timing becomes way more tedious. Great, now that all those beautiful animations have been created, we just need to integrate them in a second blend tree. Go to your Animator and at the top click Base Layer if you are still in the idle blend tree. The animations we just created have been added automatically, so I am going to remove them as well. Let's create a second blend tree by right-clicking, Create State, from New Blend Tree. I will name this tree Move Tree. Well, Walk Tree would have been better, but yeah. Like our entry point has a transition to the idle tree, we now need a transition to and from the move tree. Right-click on the idle tree and select Make Transition. This will allow you to drag an arrow to the move tree, where you left-click to choose it. You should now have this white arrow. Select it. In your inspector, you now have several settings. The most important is to define the condition when we want to use this transition. Click at the plus. In the left select box, you can now select one of your variables. For this, we want IsWalking. This changed the remaining fields to just another select box. Since this variable is a boolean, it can only be true or false. In this case, it must be true. If IsWalking is true, we want to transform from idle to walk. Also remove the checkbox from Has Exit Time. You would have to select it for determined animations like jumps or attacks. But in this case, we don't know when this animation will end in terms of time. But we want it to end when the variable changes back to false. Let's create the reverse transition by right-clicking on the move tree and select Make Transition. Then drag the arrow back to the idle tree. Like previously, remove the Has Exit Time checkbox. A warning tells us that we either need this checkbox selected or a condition. So let's add a condition for IsWalking, but now it must be false. When IsWalking is false, we will transition back to idle. Now all we need to do is to fill the blend tree like we did it with the other one. Double-click on the Move tree to open it. Here, click on the tree and change its type to 2D Simple Directional. Adjust the variables to match X and Y. Then add 4 motion fields and drag and drop the 4 movements into slots. Again, be aware that I use the order of compass, up, right, down, left. Now I can enter the according X and Y values to match those directions. By manually adjusting the red dot, quick check if your directions are correct. Well, otherwise you should see it soon when testing, because that's basically it. When starting play mode, your player should now play its walking animation. In the Animator, we can also see the current variables and the transition between those states. Since the idle animation only has 1 frame, this looks a bit strange, but you can quite good see how long an animation takes until the next one plays, which is in our case the same one again. If your animations don't want to loop, make sure they have this loop time selected. This happened automatically when creating, but I sometimes had this missing when importing animations. That just as a quick note. In the next episode, we will take a look at sprite sorting and colliders to make the player fit better in this world of tiles. Thank you for watching, and also thank you to everyone supporting me and the channel. Special thanks to my supporters on Patreon: Patrick, Naxwomo, Belgian Librarian, Ellie, and Introvert Genius. Thank you all. And as usual, if you enjoy the content, consider liking and subscribing, and I'll see you next time.